This is an old TV antenna which I'm using to turn my 2 megabit 4G connection into a symmetrical 20 megabit 4G connection, and in this video I'm going to show you the basics of how I did that. So if you not even know about how TV antennas work, the basic is that all those little pointy bits you see mounted to the stalk serve to amplify a signal coming from a very particular direction and focus that signal onto a single point where the receiver module sits, in this case my 4G modem. The reason they're able to amplify a signal in this manner is because they sacrifice omnidirectionality for receiving a signal coming from a single point in the distance. In order for a TV antenna to work, you need to aim it in the right direction, in my case the direction to the nearest cell phone tower. In order to do this, I just used a coverage map provided by my telecom provider in combination with Google Maps in order to map out where the nearest 4G tower is, and as such be able to plot a line of sight directly from my house to the tower. By then just placing my laptop underneath the antenna with a line drawn on the screen, I could easily aim the antenna in exactly the way I wanted it to be. However, since I'm a bit of a nerd, I also had access to this old spectrum analyzer, which I'm going to use now to demonstrate that this in fact does work. However, before we do, I want to put a bit of a disclaimer in here. The 4G network in my area is running on 800 MHz, which is in fact also a TV band. Often in more urban environments, the 4G runs on well over 2 GHz, much like 3G. And in that case, you're unlikely to have any success using an old TV antenna, because that's just not the TV band. Also, to this spectrum analyzer, I've got connected a little omnidirectional antenna. It's just a piece of wire, basically. And we're viewing the 4G tower I'm trying to receive here. So now I'm holding the antenna of the spectrum analyzer right in front of the antenna we're using to actually receive 4G, and as you might be able to see, we're barely picking up anything. We're just down in the noise floor. However, if I just move this back to where my receiver is, you can see that now we're getting a very clear signal by comparison. So with that in mind, as for doing the actual 4G conversion, I just chose the simplest route. Rather than trying to convert the original receiver bit which went there, I've just chosen to remove the original receiver and mount my 4G modem on a piece of plywood where the original antenna went. Connection to the modem is just made by a USB cord going to this TP-Link TLMR13U wireless router, which takes care of converting the 4G into a normal wireless network. The Huawei E3372 modem itself hasn't received any modification at all, except for 2 cheaper external antennas to give it a bit more grunt and to be able to be in 2 places at once in order to accommodate the split nature of the antenna. And to prove that this setup does indeed work, all we need to do is run a speed test on it, make a note of the results, about 15 megabits down and 20 megabits up, then turn the antenna away from the tower, and as you can see, without the additional gain of a directional antenna, we have pretty much ruined our speeds back to what it normally is out here nowhere, about 5 to 2 megabits in either direction, a bit depending on the weather. In fact, I think we might even be able to see the results live if we start a test and rotate the antenna during it. Now, if that's not in testament, I don't know what is. Thank you for watching. Cheerio.